Good morning and welcome to another session of our industry speaker series. My name is Pradeep Kumar and I'm pleased to introduce you to our speaker today. Ganesh Padmanabhan is the CEO and founder of Autonomize, a technology company applying trusted generative AI to power healthcare outcomes. He is an accomplished business executive, entrepreneur, and investor with deep expertise in data and artificial intelligence related business. Ganesh is passionate about using technology to solve the biggest challenges for humankind and believes in AI power to augment human potential. He advocates for the ethical use of data and AI and for using technology as a global equalizer to create opportunities for all. Please welcome Ganesh Padmanabhan.
Pradeep, thank you so much for the kind introduction. Can you hear me okay? So, it's a pleasure to be here, and there's a lot of folks on the call, and that's amazing. And I thank you for that, overly elaborate introduction. And I thought I'm taking a very foundational approach to this talk about ChatGPT and language models and what it means to all of us, right? And so, just before I begin, I'm CEO and founder of a company called Autonomize, and Autonomize is we started off as wanting to be the snowflake for healthcare, understanding and structuring unstructured healthcare data to power decisions across, but we evolved into a more trusted AI company with a lot of capabilities around generative AI and so forth. So I'll also be sharing a lot of stories that we have with our clients, which to make it real, right? Rather than just talking, and also give specific examples on how we were going to do it. So unless you've been living under a rock, I think everybody has actually now realized or played with or heard about ChatGPT, right? And I'm not going to ask a virtual audience of a show of hands, but I'm pretty sure every one of you have seen, heard, or played with ChatGPT. In this talk, what I want to really focus on is go a little deeper, but not too deep, making sure that we understand, why are we here today, right? Why is this a momentous moment? I'll try to make a case of this being a very critical time in the history of humankind, and definitely in the history of AI, when you look back from the future, right? Number two, we'll go into, and so once we go into the why, then we go into a little bit about the basics. What is it? What is ChatGPT? What's underlying that? What is a foundation model? What is a large language model? How does it all play together? What does it really mean? We'll get a peek into use cases, but we won't spend too much time on it, but I'll at least give you a framework to think through some of the use cases, and specifically a framework in healthcare, and also try to contextualize it, saying AI versus generative AI versus ChatGPT, how does it all play together? And then lastly, we'll think through some challenges, limitations, and then what can we all do to, if this is a momentous time in history, how do we participate in it? How do we make the best out of it for all of us, right? And so I'm pleased, and I'll leave enough time for question and answers. My slides are, it's fairly simple slides that I can actually, you can look through, and I can leave this with you after that. But I would love and encourage a lot of Q&A to get deeper into it. Okay. With that said, if you're one of those people who haven't been to ChatGPT yet, so chat.openai.com, this is what you get into as when you actually log in. And why is this actually a big deal? Why is everybody talking about it? Because of two things. It was the piece of software that got to 1 million users the fastest in 5 days. But more importantly, it went from 1 million users to 100 million users in a matter of days when they opened it up, right? Now, this is historically been the most impactful piece of technology, surpassing anything that we've ever done before, right? Including Instagrams and the Spotifys of the world, to get to that amount of scale in a very, very short amount of time. So there has to be something going. This is definitely a moment in time to pay attention to, and we'll talk about why is it and what's causing this. Now, I'm not going to go through a detailed history of AI, but I thought it'll be just important to contextualize where we stand here. And I'm keeping my timer here so that I can know I'm keeping on time. So the brief history of AI. AI was not a new thing. Everything that we're doing with ChatGPT or generative AI or LLMs have a long history. It's been a compounding effect of a lot of things that happened. And the term artificial intelligence was actually coined in the Dartmouth conference in the 1960s, and some of you might have heard of it or read about it. But at the time, the definition for what is artificial intelligence and how do you think about it for scientists and researchers at that time, there was a very important definition that came out of it, which I think is still very relevant. Artificial intelligence and machine learning and all the different things, they didn't really have the concept of machine learning at that time, is just a bag of tools for a bag of problems, right? And that's exactly how they defined it in the 1960s, right? So look at that foresight right now, and it's been so true even today because it's not one thing. It is a collection of things, it's a collection of capabilities. We'll go into a little bit of definitions very soon. But if you look at we had this, that period from 1960s, 70s, so there was a lot of exuberance on what AI is, and then you went into what they call a long extended AI winter, until what really happened, and I picked this picture from, not from ChatGPT, but from one of the things, just to frame the conversation. An important thing that happened sometime in 2010s was actually IBM Watson. IBM Watson and the Jeopardy game on live TV, where it defeated the Jeopardy champion, was the initial evidence. Now, we all have stories on IBM Watson, so I'm not going to go there. But it was actually the first time when AI became and entered into pop culture in a very strong fashion, right? And we have all the sci-fi movies in the past, but then it became a very common conversation. People started thinking about what it is and stuff. What really changed around between the 2010 to 2020 was I would say the last 10 to 13 years has been the explosion of core research. Then there's a lot of other tailwinds that also happened that led to this kind of explosion of capabilities, right, with AI, and why AI became all of a sudden so popular. But the big thing that happened in the last 10 years was the modality, the ability for algorithms. And I'll talk about what is AI just as a level set and stuff too, right? But generally speaking, it is just basically anything that you use to mimic human perception and cognition. The ability, what humans do. We read, we comprehend, we perceive, we see, we identify objects, we think about things, we reason about things. If you can do that in software, that collective set of capabilities that is used to do that can collectively be called AI or artificial intelligence, which is mimicking human intelligence and non-living things in software. Now, language abilities, the ability to understand language, and I'll tell you why this is very critical, and image recognition abilities surpass the human error threshold, right? So AI systems are much better at identifying objects in blurry images or any kinds of images, are really good at understanding human language more accurately than even humans do, right? And language is a very, very important paradigm. We live in a world where you say the feet smells and the nose runs, right? We say my nose is running. Think about it. A feet is meant to run and a nose is meant to smell. But we use language so intricately and innovatively, and there's a lot of the way the humans see the world and view the world is modeled in language. And that's why it's foundational, right? And we'll talk about the moment in time right now. But this is what happened in the last, for even last 5 years, if you will, right? Where the AI capabilities to identify objects, understand text, language understanding, reading comprehension far exceeded the human capabilities. On top of that, you had this, the abundance of a data train, right? There's always that thing that it's always true. The more than 50% of all the data in the world was produced in the last 2 years. It's been true for the last 10 years or 20 years even, right? So now all of that data is available for training these models and algorithms. And when we talk about machine learning, and I'm sure you guys all know this, but it's directly proportional. Machine learning is the art of using an algorithm where you're not explicitly telling them to do certain things for certain input versus output, You're giving them the data of inputs and outputs and asking the algorithm to learn from it. So the notion of learning. So that requires a lot of data, and that happened over the last couple of decades. Second thing is the cost of compute went down. Availability of cloud, accessibility of cloud computing, GPUs, CPUs, FPGAs, all of the different hardware innovations really lowered the barrier to entry. If you ask any researchers who've done AI back 20 years ago, or even 10 years ago, they'll say, any PhD student, you ask them, they spend the first 2 years setting up the infrastructure to build and develop the models before their research topic, right? Because the amount of work you had to do to get the infrastructure ready, optimize, do parallel threading and CUDA libraries and all that kind of stuff, it was just mind-boggling. Now you just, open an AWS account or a Azure account and you're off to the races. The last thing I would say is the research interest in machine learning and AI is AI or machine learning in general is the largest amount of students around the globe are doing research in. So that also led to a lot of those research coming out in the public as open source elements. The availability of those algorithms really made it easy for anybody to adopt innovations that are happening everywhere around the world and then build on top of it, right? So that's all great. It just tells me the story of AI, but what's different now? Remember I said language. So there's three things that I would say, they're all kind of related, but three things that happen. One is we offered a way for algorithms to model and understand the world, right? And the modeling the world is very important, right? Like I said, language, like the internet is rife with blogs that are opinions, facts, news articles, tweets, chat logs, anything that you can think of, biomedical literature, all the wide variety of data sets, which is all encoding knowledge in some fashion. And the algorithms that you use to actually train on this data don't have a contextual understanding of the world or anything, but it knows that when it's a particular set of words written in a certain way has led to these outcomes in the past. Remember we talked about the data used to train, right? So language became an intermediary, if you will, to understand, for algorithms and systems to understand what's happening in the world, right? Even when you use ChatGPT, for example, you're using human language. Now imagine 5 years ago, if you have to build an AI system to understand sentiment from a piece of text, a patient letter comes in digitally and it's got an email and they're complaining about it. If you want to understand the keywords that they're using, the sentiment of the patient in that letter and so forth, you will probably have to spin up a natural language processing model. You'll have to deploy that model. You'll have to actually then write code in either Python or C or C++, one of those programming languages, to really get the input, cycle token by token, write all the routines to go do it, train that model with a data set that you are comfortable with and you're confident on, and then get that deployed, and then apply that model on the data set to really read what's happening. With ChatGPT, you copy paste a particular document. Now there is a privacy concern, we'll come to that later. And then you hit go and say, and just in human language say, tell me what is the sentiment of this, the author of this letter, and we'll give you a beautiful description of what it is and why it said that. And even if you can probe further and say, give me evidence of where you actually got this from, and it actually will give you that thing. Human language is I would say, the big unlock that happened. You just made English, that is probably going to be the most popular programming language in the history of the world, right? And eventually other languages too. But that language understanding, the ability to actually use human language as a way to actually interact with intelligence, changed it. The second thing that happened was, you probably would have heard of this notion of transformers. 2017, there was a paper that was launched called Attention is All You Need. Very catchy title for a research paper, but it introduced an architecture of a machine learning model or of a deep learning architecture. To the simplest way to think about it is, instead of actually processing word by word in a paragraph, you just look at the paragraph as a whole and understand all the interactions and what they call attention towards different sets, the combination of words, the sequence of words, all of that kind of stuff. So instead of processing text sequentially, you can look at the aggregate of all the words and then deduce your own understanding of how it's actually shaped. And with the ability to actually then tell the model, how do you tune that attention for certain kind of patterns and so forth. So that gave a rise to this transformer architecture, which is the foundation of all the language models around the world that is popular today. All GPT, everything. It's all based on what is called the transformer model. And it's a, definitions aside, what it allows us to actually do is a few things. One, you can have a broadly capable model that can do more than one task. Like the earlier sentiment analysis example I gave you, you could only do that one task with that model. If you want to go understand a named entity recognition of certain bioentities like diseases or concerns or conditions, you have to train a new model and deploy that on the same text. With foundation model, you have an overall architecture, attention-based architecture, a transformer-based architecture that can be broadly capable of multiple things. And then you can have these tasks that you can stand up on top of that models to do specific things, more fine-tuned for particular tasks. So there's this notion of fine-tuning than just the pre-training or the training that happens. That opened up a lot of avenues. What that did was actually, when you think about what is the underlying model for ChatGPT, is the GPT, 4 or GPT 3.5, can be one broad, giant foundational model that can then be generally capable about so many different things. And the capability is actually directly a representative of the amount of data that you're actually training that, because it understands different nuances around it, with the ability to use human language to make it do what you specifically want to do and perform as a task. That innovation was groundbreaking in general. And GPT models from OpenAI by far is the leader in all the feature boards and leaderboards, but it's not the most advanced model out there. But it has captured the interaction. The last thing I would say on this is the human-machine interaction paradigm change. The use of language, the ability to actually not having to know programming languages to go make intelligent systems do things for you. This opened up everything. It also did a few things for all of us in technology. Earlier, we would actually go and build dashboards for business users to understand data. Well, they were all now being spoiled by ChatGPT. So the business is going to come and ask all of us saying, how do we actually go and have the same experience of like asking a question, getting the answer in a way that it engages me? We'll talk about that in a little bit. So what are these things? And I'll go into a little bit of definitions, right? And here, if you that little red bar, the bubble in the center, and this was built by Jeff Winter, a friend of mine, this is what captured the world's imagination. But in the grand scheme of things, from a research standpoint, from an algorithmic standpoint, or from an AI standpoint, it's one small vector of the entire ecosystem. So just very quickly going through this thing, I'm not going to go into all of the details, but to make sure you have the intuition for it. Artificial intelligence, general field of bag of tools for bag of problems. Machine learning specifically, and machine learning is relatively new compared to non-machine learning oriented artificial intelligence, which is like you were coding intelligence as what they call symbolic logic, which is basically you're writing the logic just like an old program to mimic a human intelligent action or a decision. That was a non-machine learning set of tools. Even IBM Watson originally when it launched was a symbolic engine, was not machine learning. Right? And then within machine learning, you have these different kinds of learning. There's reinforcement learning, supervised learning, unsupervised learning. Basically, how much do you help the models learn from the data, right? Do you tell them exactly this is what you should learn from it? Or do you say just learn whatever you want from it, which is unsupervised? Or if you want to do, you tell me what do you think is right, and I'll give you a thumbs up or a thumbs down. That's reinforcement. I'll give you a reward and stuff like that. In the field, architecturally, there is this thing called deep learning, which is what most of machine learning is today. Unless you're running a regression analysis on a spreadsheet or a random forest or any of these models, those are not deep learning models or LSTM. Some of these other models are, much more sequential, easy thing. But for complex tasks, the ability to actually mimic how human brains do it through a neural network of splitting up the problem into multiple layers and then aggregating it and reaggregating the answers and disaggregating the responses, independent tasks, all of these different complexities go underneath it in neural networks. And within neural networks, what we are talking about today is all about generative AI, which is basically a sub-branch of AI that is about generating net new content. And the other reason that ChatGPT captured people's imagination, it was basically the expectation gap that was missed, right? People knew AI was there, but you never really got bothered by it, but it didn't do anything that we all would otherwise do. I would write a letter, I'll write a much better letter than, having Google type up a letter for me, pre-GPT, right? All of a sudden you say, hey, write me a letter for this particular, response to this patient for this complaint and grievances. And it writes a, Oscar-winning letter, and you're like, oh my God, this is actually, I never expected this. So it's the expectation gap. Same thing with DALL-E images and things like that. So generative AI is groundbreaking because you can truly augment the human ability to create text or images or a combination or data, any kind of content. Now you can really use an algorithm to do that for you, right? Which is why I think there's a lot of research going on. There's a lot of analysts really forecasting that generative AI is going to transform every industry because of that element. I think it just gives such a huge productivity boost for everybody and anybody. We'll talk about what is it, challenges that comes with it and so forth. And within that generative AI, there is a transformer-based language models, which is what ChatGPT fits. Right. So I thought it was just an important context to go through this on this front. I have definitions on it. I'm not going to go into any of these definitions. What really happens in these OpenAI models, if there's any other questions, I can actually address that during Q&A. The core to this thing is called what they call the large language model. Remember I mentioned that language being the intermediary between intelligent systems and human beings and tasks and activities and so forth. I think this is the huge opportunity for every industry, right? Because now you remove the need for anybody having to learn a new programming language, understand a different instruction set, or you can use a common way of communication that we're all naturally good at as humankind to operate and train and modify these complex engineering marvels that are generative AI systems, right? And so here's an example. This is I'll give you this is our Autonomize architecture. We build large language models across all the different, that support the modalities of multiple kinds of input data. It could be HR, EMR, financial data, public databases, research and literature, the whole 9 yards. And then we turn that into what they call embeddings, which is a dynamic knowledge representations of that data that can then be queried, ask questions about, summarize, visualize. You can connect with an API. You can build different apps on it. So deliver multi-dimensional experiences. We'll talk about these specific use cases in there. And then doing that in a private setting, in a private environment with private data set, ethically and responsibly, is where we're building the business. Over time, I'm sure even the ChatGPTs of the world, they launched a privacy setting update yesterday, which by default, the chat that you type into the model is not used to train the model anymore, starting yesterday, which is huge, right? It gives people confidence that you're not going to misuse the data that I type in. It still is taking the data out. It's still not HIPAA compliant, the whole 9 yards. So, but I think those are engineerable problems that will be solved over time. With that, let's get into a little bit of use cases, and then we'll talk through some challenges, and I'll pause for questions. So let's go into some of the use cases. And I think, look, I would have actually, and I'll send you as a follow-up if you're interested. We can go deeper into healthcare use cases. We can go pick apart every single aspect of this thing. But I like to simplify. I like to actually really, give people contextual understanding and ask, how do you actually go? And I was a professor, so visiting, I was an adjunct professor, so I'm used to teaching in a way that you build intuition and then everybody can actually go figure it out. So there's a few things. I'll give you a general view, and then I'll give you a very specific view on healthcare where this opportunity is, right? So generative AI, subset of larger AI, it's not predictions, it's not different things. There's obviously what is really happening is predictions. One last thing I would mention before I go into use cases. What ChatGPT is really doing at the core of it is a glorified autocomplete of your sentence. You type a word, it'll predict the next word. And then when you do that in sequences, you build sentences, you build passages, you build paragraphs and stuff. But all it's doing is doing a next token prediction or a next word prediction that is just predicting that word. And how is it predicting that? Well, based on all the inputs that you actually have seen in the past, given a particular word, let's say how are, most of the data samples being trained on, how are is always completed with you, with a question mark. So it predicts that as the highest probability and is doing. So it's a predictive system. It's a probabilistic system. And that's the simplest way to describe ChatGPT or any of this thing. It's a beautiful, glorified autocomplete system that predicts the next word or the next sentence or the next paragraph, right? And so that's what it is. Now, large AI field, you can do a lot of things. You can do predictions, you can do projections, you can predict an outcome of certain things and so forth. And then there is a subset of generative AI, which is creating new content. That content can then be actually think about what kind of content. There's only 4 broad kinds of content that we are creating today with generative AI systems. One is visual content, which is images. So the famous things are the DALL-Es of the world, the stable diffusions of the world, which you can, again, important thing here is language is still the intermediary. You put the text language in saying, I want you to build a picture that looks like 1, 2, 3, and these characteristics in a Renaissance era style, and brushstrokes. This brushstrokes will be in a certain fashion, and it'll generate that painting for you. So that can then be used for building new imaging, enhancing images. Things like denoising images is a huge opportunity. That also means I'll come to a very specific machine learning oriented use case, which is you can create synthetic data that is now can fill in missing gaps in longitudinal data sets for patients and so forth, but also get into things like you can create a lot more trainable data sets for your algorithms and so forth. That is used for any kind of image creation, could be video, could be individual images, could be 3D shapes, all of the different modalities. Audio generation, you've actually seen it. I don't know if anybody saw the news on how Drake composed an AI generated music thing last week, which is pretty awesome. And it also raises a lot of copyright issues and stuff like that. Again, we'll get into that very soon. Text generation, the classic example is ChatGPT, but that can be plugged into a chatbot, right? The one thing that I mentioned that, and I will talk about healthcare use cases, we noticed that, it's the same problems everybody's still trying to solve, but the expectations now have completely changed, right? Instead of actually giving a person a BI tool with a search bar where they can type keywords and find out what they're looking for, the expectation from the business is, how do I ask a question and get an answer generated for me that captures the essence of what I'm looking for, right? So that is where generative AI can be plugged in as an augment to your existing use cases. The last thing is the code generation. And this is the, we used to do all the interviews. We used to have, we used to give people coding exercises for our engineers. Every one of them use ChatGPT right now, right? GitHub Copilot. But, basically you can generate code. But here's an interesting way we use, right? So we have a product that we actually, sell to pharmaceutical companies and life sciences organizations on, digitizing clinical trial protocols. So if you want to run a search on a large database, the protocol is a lot of blob of text. It has got different procedures, conditions, timelines, requirements, different eligibility criteria for patients. We apply NLP, turn that into, what are the codes, what are the things that you should be looking for. But then the schema where you're actually going to run that search might be an FHIR schema, could be an OMOP database for research. It might be a traditional, patient database or a registry, which will have a different folder structure and table structure. So we use generative AI to auto-generate SQL code to run, or not just SQL, but if you can actually prompt and give it different things, to take the intelligence that we just curated into this thing, and we don't use ChatGPT, we use our own models, to turn that into the code that is needed to go run that system. The implications of this is huge, because in IT, in all of us, and I grew up in IT too, right? The amount of glue code that we write to connect systems and integrate systems and processes can all be rethought about, saying, how do you auto-generate code fit for purpose? And then you can build a lot of these different, we'll talk about something in the future where AI becomes truly invisible. We can really automate a lot of the things behind the scenes as well. But that's the other large set of this. So this is a framework for you to think about generative AI use cases. In healthcare, I would say, there's a lot of noise, lot of things that you will hear. You know, everything from digital twins to, you know, autocomplete for EMR to, you know, the Epic and Microsoft announcements with GPT-4 integrated into Epic. All of that stuff you will hear, right? But I think all of these things can be categorized into three buckets. And I'll give you three specific examples. I'll show you a quick example of how, you know, we use it in a thing too, right? Number one is reducing the administrative burden, specifically as it relates to documentation, right? So there's two parts of this, right? One is administrative cost comes in when, you know, if you're like, I'll give you two examples. One is we help, you know, Autonomize in my company, we actually help a lot of clinical research organizations, or, you know, or even large sites, integrated sites, recruit patients for clinical trials. If you have to review a patient's medical history, even though, you know, the structured data in the EMR is actually very structured, you have all the ICD codes and CPT codes and stuff. But if you look at a inclusion or exclusion criteria for a particular patients for a particular trial, it is a lot more nuanced than that. They'll have things that cannot be automatically turned into a structured query. So you have to understand the essence of it and so forth, right? For that, principal investigators, clinical research associates, nurses, and clinicians review piles and piles of documentation. A great example is lab reports, right? If you have a pathology report, you have to review it and read it, every single part of it, to really understand what the impressions are, what are the actual, you know, staging of the particular disease, how is the progression actually been tracking over time. It's a very manual process to go do it, right? Perfect example to use, you know, generative AI to go automate the extraction of that and summarizing it and contextualizing it to what they're looking for to make a decision. So we were able to go, you know, for large CROs, go from 9 months to do patient recruitment, you know, patient eligibility checking. And believe me, 9 months is actually a pretty aggressive timeline in their minds, because they're talking 40,000 patients, reviewing about 3,000 to 4,000 pages of documentation for all those patients, right? And they have 40 different trials running at the same time. So all of that put together take a long time to do it. We were able to cut that down by less than half of that time. The other side of this is actually, if you have clinicians that are actually using, you know, like documentation, I'm sure every single one of your clinicians will tell you more than 50% of their time is spent on clinical documentation. You know, be it writing up discharge summaries, be it writing up your end of day notes, and doctors actually all work outside their shift hours to go and write up and spend a couple of hours on an average to go do it. Great opportunity to, I mean, that's where the Epic, and if they can integrate GPT-4 in a secure manner within Epic, I think it'll be a great opportunity to completely reduce the cost of, you know, that, you know, it'll be a lot, you reduce the burden on the physicians and documenters, if you will. But there's also a lot of things that you can do, right? Writing up research reports, writing up things that, you know, are a little bit more like, you know, how do I write a grant, right? For a lot of doctors and folks. It's a really hard problem. It's a great use of using generative AI to go do that. And it won't be perfect, but it'll give you a starting point so you can actually go from there. So there is like reducing generation of content, be it images, be it text, be it documentation. How do you reduce administrative burden doing that? One theme that you can actually see. The second theme is improving engagement. And I call it broadly engagement and activation of constituents, be it employees, physicians, patients, and so forth. And I'll show you an example, which is what makes a huge difference, right? So generative AI, like the notion of this is actually, how do you use human language as an intermediary, right? So if you actually, as in IT, let's play the scenario out, and we did this for a large payer, wherein we set up a dashboard for doing chart abstraction. Everything that's on the unstructured data on the charts is beautifully put together in a chart, in a single page summary for a patient, about a patient, you know, and they ask the question, you know, you can just look for saying, what are the conditions and what is the longitudinal way that the, you know, what is their medication history, what dosage, everything is beautifully arranged and so forth. And we noticed that clinicians, nurses, and medical directors who are doing this is for a prior auth kind of a use case would still go back and look at the core documents. And the reason was they always felt that, you know, when engineers put these things together and surface it for me, they really are not packaging what I've told them what I need to look for, but I need to look at other things because I'm a physician, I'm a clinician, I know what to look for, right? but they still have to go through that 500 pages of documents, if it is, to actually go page by page to look for what they're looking for, and then read that in detail, and then extract and synthesize and understand and stuff. So we had this, chart abstraction view, which was a simple view of actually just organizing data in a structured fashion, which was, highly useful for their workflows. But the adoption side was these, a lot of folks were not adopting it. So we added a small generative AI capability to that same thing. Ask a question off that document. Ask anything that you want to understand about this patient in that set of documents that you have access to, and it'll give you the answer. What we noticed was the clinicians who were using that system preferred that approach because it really brought out what they were really good at understanding. I know exactly what to ask. And then they're also not looking at things that are organized by somebody else who's not in the game doing what they do, right? So it also improved the engagement and stuff. The same thing can be done on the patient side. If you're doing patient engagements, I'm sure like everybody has apps right now. And most applications which are built on, let's say, an Epic's front end that we use, it's a terrible user experience. Most people are very comfortable doing, text messaging or chats or, even voice-based communications using human language. It provides an opportunity to turn that interaction pattern with the constituent in a very, very natural fashion that'll make a huge difference. And the last theme that we have found is a co-pilot to create and brainstorm, right? This is an example where I fundamentally believe that the opportunity with AI is to make everybody an Iron Man with their own Jarvis suits, for a Marvel reference, for those Marvel fans out there. But you can actually use ChatGPT, for example, is used for brainstorming. Hey, give me 5 ideas that I should think of for this next blog that I'm writing. Well, replace blog with this research papers. And you can give it more context and say, a generative AI system, and say, hey, this is my past work that I've done, and this is what I'm trying to actually write a research grant proposal on. What should I be focused on? And it gives you, it stops what they call a creator's or a writer's block, as they say it, right? So you can apply that to any knowledge worker profession, which requires you to be creative, but then how do you get off that starting trouble, right? That's the huge opportunity there. So I have this example of a very, very short video, and this is Autonomize's thing. And the example that I actually showed you was this thing that, we have, let's say, I'll just go to a very quickly on this scene here. So we have a patient, and the patient's data is, so this is the extraction that happens on the particular, this is the core documents, these are all synthetic data. You're taking the, applying NLP or natural language processing on it, and you've organized that into a way, this is very structured about the patient. So single page summary of a patient, which is great, right? I think, it really helps a lot. What really made the difference in getting that adoption was this very simple thing, which you ask a question. And this is what generative AI gave us, right? So augmenting your existing workflows with, more generative AI capabilities will be the huge unlock. As sexy as it, as non-sexy as it sounds, but that I think is the bigger opportunity right now, to focus on those things that reduces administrative burden. And then you got to do all the things that are necessary for, healthcare and the regulated industry. So like, for example, what we do is evidence and explainability for everything that we're doing, right? So things like that. So I just thought it was just to make it real, to give you an example on how this works, okay? Sorry, 1 second. Okay. So like I mentioned, the big opportunity as I see it, and I've said this like for the last decade that I've been in AI, the big opportunity is to build these Jarvis suits. So every single clinician, every human being can become Iron Man with an intelligent Jarvis suit, an AI copilot that makes it happen, right? Now I have 2 short sessions, but I want to actually leave questions for time for questions. There's a couple of misconceptions that I want to spend a little bit of time on, but we can also answer it. If it doesn't come in as Q&A, we can actually come back to it, right? The usual things. Will it replace human jobs and things like that? So I have arguments for all of that. And then let me just spend 5 minutes on limitations, right? There's actually, you got to think about, most organizations are providing guidance on how they should use generative AI tools, like especially the publicly available tools like ChatGPT. But the concerns can be actually looked across as like three broad buckets, and a fourth one because there's a lot of noise on it. One is data privacy and security. The most basic thing is you don't want a non-HIPAA compliant system having access to PII or PHI data that goes into a cloud that gets trained and somebody else is querying, hey, build me a sample synthetic medical record for a patient in West Coast doing blah, blah, blah. And all of a sudden they actually get an inspired chart from Kaiser that somebody uploaded to train to get a summary on ChatGPT, right? Number one big problem. There's a lot of ways you can solve it. We use like privacy filters that if you still want to use ChatGPT, you can use our filter that'll filter out the PII, PHI data and then send the others to go do it. Or you use personal private models to go do it. I'm sure the cloud vendors will also, like Microsoft and Google's the world, will start doing some form of regulated, industry-friendly, dedicated instances to ensure data co-location and security and virtual private cloud kind of deployments and so forth. So that's the easy part. The second big thing is the ethical consideration, right? Bias and harmful content is the two big things, right? You all heard the stories of the New York Times journalist who the Microsoft bot asked him to leave his wife and start a life with the bot, Sophie. You probably heard of the kids that were encouraged to commit suicide because of harm content. There is no easy answer to this problem, right? There's a lot of foundational thing. You realize that these models, these large language models, are built out of a lot of data. And that data includes everything from the medical literature that's on PubMed to clinicaltrials.gov to all the news articles that are factually checked to tweets from our former president to dark websites that are actually doing conspiracy theories to Facebook feeds. There are so many different things, and you can't really, these are evolving systems, if you will, that you can't really restrict what it actually derives its inspiration to generate the content from. There are ways to do it. One approach that we use, and it's very popular, becoming very popular approach, is called retrieval augmentation, where you narrow down the scope of where you have to inspire from the embedding space. You would inspire the generation of the documents from. Another way to do it is the human in the loop thing that OpenAI is actively doing. You'll always have things that are missed out, but then you'll constantly iterate on it and stuff. The third thing is actually also fine tuning with non-biased data sets, these available models that'll actually go do it. The third thread is the biggest thing that I worry about, which is the unintended consequences and bad actors, right? Like any other, this is no different from any other technology. We'll have it, we'll see misinformation campaigns. It's going to happen. We'll have to see the bad guys are always going to start to take advantage of the stuff to the bad things. And the only thing, historically has shown is we've also been good at being the good guys, and there are more good guys in the world than the bad guys. Doesn't solve it, but it actually also leads to how do you put the right regulatory measures in place, a lot of self-governance initially from organizations like yours and ours to go do it. But then over time, this will hopefully get into a very interesting space that it becomes more standard operating procedure, right? And policies will be developed, all that kind of stuff within the organization. The last part is there was a letter that was signed by everyone from Bengio, the Montreal professor, big Turing Award winner, to Elon Musk on we should pause all the experiments on building new systems for 6 months for regulations to catch up, right? I don't believe that would have worked anyways, but it didn't really go anywhere. It just created this debate of saying, are we in the realm of AGI or artificial general intelligence? Part of that is also very definition oriented, right? I mean, an artificial general intelligence is nothing but, it has generally intelligence across a broad variety of topics, can operate like a human being. In a lot of smaller domains, it can still, ChatGPT can do it. But does it understand, does it have consciousness, understand what it is? There's no evidence yet. There is a lot of evidence of new, what they call emergent capabilities, right? New capabilities that the models are exhibiting and experiencing. But again, I think that, to do something bad, the models alone, it has to want to do something bad. So the risk is more of the number 3 of bad actors using these powerful models to do things, and the models deciding to just eradicate humanity, right? So somebody has to prompt the model or all this kind of stuff. So last thing, what does it mean to you? The easy thing is everybody's like freaking out on FOMO. We see this everywhere, every organization. Don't freak out. If you're not in the business of building cutting edge research on AI, you will be fine. Let all the wars go on between Google and Baird and Bard and Sophie and all the stuffs. The cost will come down. AI will be further democratized. We're still way early in this space, right? The hype is way higher than reality, right? There's a journal for JMIR did a systematic review of all this research that's been done. Clinical decisions augmented by AI are not yet proven to show considerable improvement over clinical decisions you done without the use of AI. So we're still way early in the space. Third, be wary of the snake oil vendors. ChatGPTing everything, generative AIing everything. These are just tools, bag of tools for bag of problems. And lastly, I would say how you can all win is focus on the problems. Focus on the problems you want to solve because you're the expert in that problem, right? And then you just got a new bag of tools that you can use to experiment, right? There are some other, frameworks which we don't have time for, but learn, read, talk to a lot of people, experiment as much as you can. Organizationally, we tell our clients to say, look, focus on the problems again, and then activate by adding, pieces to the workflow, then trying to say, let's just rewire everything with a generative AI first mindset is probably not going to work. Definitely not in healthcare. I mean, even other industries, it may not work, right? And then you accelerate, you build out your capability set, there are some new skills to be developed organizationally and so forth. And after all of that is when you can really accelerate on this. So my last slide is it just became more understood overnight. We don't have to do what is AI presentations anymore. It became more accessible with ChatGPT and all these large language models. And the last 4 months has been historic in this world of this thing. It became more personable because now you truly have an AI assistant, albeit only to do your summarization and generation of content and so forth, but this can be extended to other things. It's becoming more and more democratized. You don't need to have large data centers, a lot of engineering talent, a lot of data scientists to do anything groundbreaking anymore. The last thing I would say is it will become more invisible. And there's all these out there kind of things that, in a future session we can talk about. There's a couple of papers you should look for. One is called Tool Farmers. The other one is called Hugging GPT. These are basically, you're using AI, so not just the GPT models, not just to do the reasoning, but take a task, break it down to subtasks, and select the best task, and go run that task, come back, aggregate the result, and roll out the results. That whole thing of trying to build autonomous systems is coming, and it's going to happen. It's going to be really hard to implement in enterprises and stuff, but you can start seeing this happen in the consumer land. You can start seeing this happen to make life a lot easier in a lot of different ways. It's not to say it's not possible within the enterprise, because there's a lot of unknowns in the space. It was very, very, very early in this regard, but it's very exciting. And I always like to say, right, like the future is so bright that we all need shades, right? There's a lot of things that's going to happen.